Hi there. In this session, I'm going to introduce you to the log search feature in EventTracker 9. It's been completely redesigned from its predecessor in EventTracker version 8. It's now based on Elasticsearch, a NoSQL solution that has enterprise class facilities and is blazingly fast. In addition, it's incredibly powerful in its ability to look for data, and you can be as precise as a surgeon with a scalpel. Here's the problem with log search. In the enterprise, at a minimum, you got to deal with the 3 V's. Logs come at you at great speed, the velocity problem. They come at you with a great variety. Every vendor has their own format. And then you have the volume issue. You get gobs and gobs of these logs that you have to deal with. This leads to conflicting requirements. On the one side, you want to be able to store these large volume of logs very efficiently for relatively long periods of time. The norm is 12 months, 1 year. But then that conflicts with the other requirement that you want to be able to retrieve it really, really fast, and then equally important, pivot from one to another for the security use case. In EventTracker 8 and earlier, we tried to solve this problem by late binding. This means that we receive now and understand later. We call this fast in, smart out. While receiving data, we didn't bother necessarily to understand it all. We just took it in as quickly as we could. And then at the back end, we did indexing and other kinds of things in order to improve the performance at display time. Now, this is highly efficient because we get better than 90% compression in storage. And so that solves the volume problem. But no matter which way you cut it, it tended to be slow because you had to think about the data before you could actually present it. And so users, being notoriously impatient, would always stamp their feet. Now, to solve that problem, we did in fact offer a data warehouse called the Event Vault Explorer, which did some amount of normalization, some amount of indexing. But frankly, indexing still happened at best on the hour, which was far too slow for the security use case. Further, it was based on ODBC, Microsoft SQL, which scaled to a certain extent, but was much, much more expensive in terms of CPU utilization and, of course, the license. The ideal solution to the 3 V's, if you set aside the technology of EventTracker 8 and said, what does it take to really solve this problem? From the variety side, the problem is that it's a Tower of Babel out there. Every vendor has their own terms, their own format. So a solution would be normalization. Have something common, a common indexing model, a CIM, if you will, so that you can reduce everybody's language and terminology to a common one. To solve the velocity problem, it's a good idea to receive now and index later. But then, since that gives you problems on the display, you should in fact look to bind early, not just late. So early binding is a good thing, but then you should not overdo it. It's preferable that you do it just in time as needed, so that you're not slowing down the receive process at all, if any. And then lastly, volume. Frankly, we had this nailed in version 8, and we continued that tradition in version 9. We archive logs with excellent compression. On average, you get 90%. That means 100 bytes of log as we receive it on the wire winds up only costing 10 bytes on disk, which is very, very good. So bottom line, EventTracker 9 kept the benefits of late binding and highly efficient storage, but they added normalization and fast search and did all of this by also getting rid of the underlying data warehouse based on ODBC. So no more SQL, no more license cost of SQL, no more CPU cost of SQL. That, we think, is the ideal solution to the 3 V's. So how does this magic happen? Well, the speed is achieved because in a variety of methods. First of all, log data is received in any one of the numerous supported methods. It could come at us as syslog. Our EventTracker Windows sensor could send it. We could get it as a file transfer. We could get it through network file share and so on. Apply the common indexing model and then store it in Elasticsearch. And here's where the speed part comes in. Elasticsearch is an open source enterprise class search and analytics engine that is blazing fast. And of course, we keep this data for only n days, typically n is 7. This can be adjusted in your installation. How do you do storage efficiency? Well, this is frankly the same as it was in EventTracker version 8 because we had pretty much nailed it. We take the data to be archived, compress it, and index it using XML indexing. This gives us on average 90% compression ratios. And then you purge this after usually a year or more so that you have data available to satisfy the compliance use case. Now when you're searching, as you are in EventTracker version 9, you can search from either side. You can either search in the Elasticsearch dataset, which is usually the last 7 or 14 days, or you could search against the archives, which is the last 1 year's worth. Now I mentioned the common indexing model. What is it? Well, the common indexing model is a shared semantic model, and the idea is to extract value from data. Essentially, it acts as search time schema, and it normalizes the data to match a common standard. This is a standard that we here at EventTracker have defined, and it's specifically built in order to satisfy the security and compliance use case. It allows you then to do reports, correlation searches, and dashboards in a uniform manner regardless of the log source. It also enables pivot. You can follow hunches quickly. This is a primary staple of the security use case. And you can go up and down the search results, and you can go laterally as well. How does this work? Well, we've retained many of the aspects of EventTracker version 8. So as usual, we receive data in any one of the supported methods. And then we apply this common indexing model and store the data in Elasticsearch. But the original data continues the same as it did in version 8 and gets archived with better than 90% compression. So let me show you how this works. You can launch search in a variety of ways, but the simplest one is to use the search option in the main menu. Clicking it brings up the search options, and you can either search by providing a Lucene query, or you could have one constructed for you by using these options, or you could simply say, regardless of the query, just give me data for the last, say, couple of hours. And here you could either choose to specify the log sources, or leaving it empty suggests everything. You could say last couple of hours, you could make it relative, or you could have absolute times. I'm going to pick last couple of hours and go ahead and search. And so here are your results. You'll see the results are broken up into a couple of different panes. At the top is meta information. It shows you information about the results. What are the hosts? What are the destinations? What are the users? What are the machines? What sorts of log sources have come in? What kind of tags do I have? You can collapse this if you're not interested in it. And below that, you're going to see timeline, where you can further drill by time. The actual results themselves are available here, and these are expanded in an accordion. And as you can see, they represent all sorts of logs from all sorts of log sources. Arrayed on the left are CIM fields, and you can expand these in any way. For instance, to understand what were the source IP addresses that were shown, here you have it. Or if you wanted to know what were the applications that were seen, you can see this here. And you can choose to expand, filter using any of these plus or minus buttons, so that here, for example, is information from an application called SSMS, and you could choose to see only stuff from SSMS, and here are different sorts of logs in the 2-hour time frame for it. So this is how you do basic search. An option when you're trying to search rather than trying to construct Lucene queries is to use saved searches. These are a number of searches that get imported into the system depending upon the knowledge objects that you introduced. Click on saved search and you can go to predefined, and you'll find a variety of already defined searches available for your selection. For instance, if I were interested in all error events, say over the last 6 hours from any log source, then I would simply select that, and as you can see, the results are available. As usual, the top part shows me meta information, the middle part shows me a timeline, and then the bottom part actually shows me the actual results. Notice that you can filter maybe just by simply clicking on a particular portion of any one of these, and including or excluding the events of interest. You can of course expand these accordions in order to see the specifics, but you can also customize your display. For instance, what are the log sources that these logs have come from? So here I've quickly done a column which tells me where they really came from. I could also maybe decide who were the users and perhaps more information about what the log type especially was, or what the log information is that's available. And so you can see agent configuration attempt, or there is a kernel context, or there is no event heartbeat messages, and so on. So saved searches are a powerful way of getting to information, and you get these the moment you import knowledge objects. Log search in version 9 is powerful. Because of the common indexing model, you can pivot quickly from one to another set of search results in order to investigate. Let's take a look. Here, for example, is an FAQ tile suggesting that maybe we have insider threats. Insider threats maybe are users that might be created, promoted perhaps to an admin, or joined to a security enabled user group, as a for instance. So if we click on this, we take a look. As we hop past the meta information in the timeline, what we see is that at 7:07 a user account was created, and the person doing the creating was an administrator by the name of Kenneth, and the account that got created was for a user by the name of Anderson. Just about a minute later, you can see that this user gets added to a security enabled user group. So this is something that we would really very much like to investigate. Well, we can pivot quickly based on the user Kenneth and try and understand what is it that Kenneth maybe has done. So I clicked on the Kenneth username and I got switched over to a view, and you can see this here at the top, where if the user was Kenneth, then what has he done in that same time frame? And what we see here is that since 7 o'clock he's logged on, he's created the user, he's added that user to a security enabled user group. It looks like the user at 7:09 then has tried to insert a USB into a domain controller, but that has not been allowed by EventTracker because it's not part of the policy. You have to use corporate USB sticks. If you're going to use them in the data center, you can use your own personal USB sticks at your desktop. That's the policy here. So at some point later he decides that enough is enough, and he asks to log off, and he logs off. Well, about 10 minutes later, this is 7:10, this is 7:21, it looks like this user Kenneth successfully logged on and then deleted that same account called Anderson, and then cleared the audit log a couple of times to be sure. Well, whatever might have happened in that 10-minute window, because it's very unusual that an admin would show up and that he would do all of these kinds of things from his workstation. So workstation 8 is where it's at. We've pivoted from looking at the fact that there was a potential insider threat to what that admin had done. And now we're going to pivot again and look at what happened on that workstation 8 in the particular time frame of interest. So what we see here is this is Kenneth logging on. We saw all this already. We saw him creating the user, but we now also see him trying to log on as Anderson and failing to do so, possibly because he mistyped the password of the account he just created. But then he successfully logs on as Anderson and immediately inserts that same drive here in workstation 8 that he tried to install on the domain controller. And because that's allowed now, EventTracker begins to monitor it to see what's going on. About a minute later, we see that BitTorrent gets installed, and then a new process that we had never seen before starts to cross the memory limit and then creates a connection from here out to YouTube, right? He then removes the USB stick and then clears the log, initiates the log off and gets logged off, and ultimately deleted. So the question really is, was this legitimate? Because it certainly looks highly suspicious. What should you take away from this as far as EventTracker v9 log search is concerned? Notice the ability to switch and pivot quickly from one to another. If you're a security user, then this kind of capability is very critical if you want to follow hunches. Now, I showed you drilling down. Here's me going back up. So I went back up to the case where I had Kenneth as the focus, and I can go back up further to where I was looking at the original insider threat. So you can drill down, you can go laterally, you can move back up again. You have these meta tag capabilities to show you what the data is looking like, as well as the timeline if you wanted to narrow down on a particular time frame. And of course, with the interesting fields and the actual logs themselves, you've got a ton of power at your command. Log search in EventTracker 9 can also be extremely precise. Consider, for example, that we wanted to just simply look at all traffic over the last one day. But then we decided we didn't really care about local traffic. And local traffic is in the 172.30x.y range. Why, you could use a wildcard like you're seeing me doing here using CIDR notation, and use the not boolean in front of it and search. And having done that, you're going to get results where the source IP address is not in the area of 172.30. As I look through the results, I realized that really my wildcard wasn't enough. There's a 172.16, and then there's also a 192, which is also local, as well as a 127.001. Well, I can go back quickly and redo this query, and here's the precision part. I can redo this query saying, I don't want results, show me any results, but not if the local source IP is 172. anything, or 192.168. anything, or indeed 127.001. Again, I simply pick the time frame, and away we go. And so you see a sequence of results now precisely measuring what is it that we asked for. So we said we didn't want to see any local traffic, and sure enough, we don't. We can now dig this further and say where is traffic coming from, for example, and realize that either it comes from Dublin, Ohio, or it comes from Japan. So if we wanted to focus on Japan, we could simply filter to those results and move along. So you see, once again, the capability of being extremely precise thanks to the use of Lucene and Boolean variables, including and, or not. Another example of this was available when you saw the potential insider threats that I showed you a little bit earlier. The actual Lucene query that we did in order to fetch those results looks something like this. So you can see that this is a mix of and, or not, and you can have up to 1,024 such clauses as part of any given Lucene query. That makes Lucene and EventTracker v9 log search not just incredibly powerful, but also incredibly precise. Recognizing the centrality of search in the security analyst view of SIM, we have promulgated a vision called From Search to Anywhere. The results of the search can be shown as a dashboard, or in fact can be saved as a saved search. The results can be exported, the criteria can be saved, and of course you can add the search results to a casebook. This fulfills our vision of From Search to Anywhere. Let's look at an example. I'm going to enter a query that allows us to look for any vulnerabilities that might have been detected by the EventTracker vulnerability system in the last one day. So here I am populating my query. I'm saying tags star etvas, and this is another powerful concept in EventTracker v9 search. All of the knowledge objects are tagged, and instead of caring about specifically the device that's emitting, you can choose to use a tag. So here I'm saying if the tag is etvas, you could do things like tag of authentication failure, and you'd get logon failures from pretty much any log source that's reporting in. But here we did tags as anything relating to etvas, note the use of the wildcard, and you can see that the results have actually shown up. So you can see that there are a number of threats, vulnerabilities that have been detected, and there's threat information as to what it is. Now you can choose to save all of this as a dashboard. So you simply say add to dashboard, provide a title. We'll call this thing test. Maybe provide some notes. Say what is the period that you want it to normally run against. And then you can plot pretty much anything you like. So let's say that we wanted a stacked column, and we wanted to see in the stacked column the threat category against the source machine. You can now test this and see what that looks like. So you can see that there are a couple of these vulnerabilities. Now, secure hash algorithm, the RC4 cipher is untrusted. You can switch this around and decide that you'd rather see the source host name, and then you'd rather see the threat category here at the bottom. Having done that, testing now, and you can see specifically at the bottom in the legend, and you can save this to a dashboard. So that shows you how you can use search and then actually save this as a dashboard. You can also add the search and its results to a casebook entry. That is, you can either make a new case or add things to an existing case. So if you're searching through stuff as part of your investigation, you can open a case and then add stuff to that case as you get going. That's from search to everywhere. In EventTracker v9, you can also go from everywhere to search. Consider this. On the threat map, we see a blinking dot, which suggests that we've had a visit from an external IP of poor reputation, and it happens to be from Karachi, Pakistan. Clicking on the dot allows me to see quickly that this address in Pakistan has been communicating with us on an inside IP. And I said from everywhere to search, and here we are launching a search for those logs where the local IP and that supposedly bad IP from Pakistan are both present. Skipping past the meta information and the timeline, you can see that there has been an attempt by Winword to go to a website called NeoGenomes, and this is where that evil IP happened, right? That's the evil IP itself. The local address is the 5.110. Well, that happens to be Contoso Marketing Workstation. So of course, with the power of the CIM, you can quickly pivot and take a look at what's happened here. And what we see is at 6:18, an account was logged on, Outlook was running. There was an attempt at connecting Outlook to Exchange, but then suddenly there was a new process that was created called roaming.exe, and then you have what looks like it's ransomware because your files are dead. So as you can see, you can go from everywhere, in this case from a threat map, directly to search, and then have the ability to pivot around in order to follow your hunches at scale. So that was a demonstration of the log search function in EventTracker version 9. You saw the Lucene query that allows you to get that precision, or the wizard GUI that makes it easy to construct queries, meta information on the results, and the common indexing model that makes it easy to pivot and save searches. A lot of searches available built into the system. You can also go from the search results to pretty much anywhere. We showed you examples of saving results as a dashboard or to export them to a case. And of course, you can go from everywhere to search as well. We showed you from the threat map to the search. We showed you how the FAQ tiles can lead you to search as well. That's EventTracker 9 log search. Powerful, precise, and fast.